In Viva, this question can definitely be asked. What is the difference between resistivity and resistance? So resistance is nothing but how much a wire provides resistance to something, how much it opposes the current. So opposing of flow of current is called resistance. Okay, so resistance is the opposition of any wire to the flow of current, whereas resistivity depends on material. Every material has some kind of resistivity. It has some resistivity value that is known as resistivity. Resistivity depends on the material of the medium. Resistivity depends on what the medium is. Copper has a specific resistivity, iron has a specific resistivity. So like that, specific materials have specific resistivity, whereas resistance is nothing but it's just the opposition of flow of current. So now the most important thing that we must learn in all the experiment is first the diagram. So I am going, whenever I explain any experiment, just by using the diagram I am going to explain you everything that is involved. Okay, so we are going to determine the resistivity of two or three wires. So first let me tell you the formula. Before I start everything, let me tell you the formula. You know, resistance is equal to V by I. This is Ohm's law. Okay, voltage divided by current, that is resistance. Okay, that is my resistance. Whereas resistivity is nothing but resistance into area by length. So basically resistance is nothing but resistance depends on length. See, if I increase the length of any medium, its resistance increases. If I increase the area, obviously resistance decreases because area is big, current can easily flow, so resistance decreases. Proportionality constant is known as resistivity. Proportionality constant is known as resistivity, which is depending on the medium, material of the medium. So from here, if you separate this resistivity, you get this equation. That's how we got that formula. Okay, so the entire formula is basically based on resistance equation. So this is the most important formula that we need to know, and this is the formula which is very important in this experiment. So resistance is voltage by current, because V is equal to IR, that is Ohm's law, and resistivity will be equal to resistance times area divided by length. Now the circuit diagram for this is going to be, since we need potential, we are going to change the potential. See here, to find resistance, what we require? We require voltage. Correct? To find the resistance, we require voltage. To find resistance, we require voltage and we require current. Voltage is measured by voltage is measured by voltmeter. Sorry, voltage is measured by voltmeter, whereas current is measured by ammeter. So what are the things that our circuit should consist of? Our circuit should definitely consist of a voltmeter, and it should consist of a ammeter, and it should also consist of a wire whose resistance we are going to measure, because we are going to measure the resistance of a wire, right? So these three things are the main requirements apparatus. Along with that, definitely you require a battery, because every electrical circuit will require a battery, right? So all the devices that we are going to use in your 12th are going to require a battery. So these are the devices. You can write requirements in that. So voltmeter, ammeter, wire, and along with that you require a rheostat. I will show you the diagram. So basically we have a battery here, and this battery, see, this is positive terminal of the battery, long side, and short side is a negative terminal of the battery. Remember, you must be very 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 important for you to remember. You don't have to complicate the things. Okay, the positive side of the battery is always connected to, we require an ammeter here, right? So positive side of the battery is connected to positive side of the ammeter always, and negative side of the battery is connected to negative side of the ammeter. So here we are attaching an ammeter directly to this, so the positive side of the ammeter comes here. Next, what we require a unknown wire. This is my unknown wire whose resistance I need to measure, and parallel to that, always whenever you want to measure voltage in entire physics, whenever you require to measure voltage, the voltmeter is always attached parallel to the circuit where you want to measure the voltage. I want to measure the voltage across this wire. I am seeing my wire how it is changing the voltage and current. So I require that. And what will be this? This will be positive side of the voltmeter or negative side? This part. This will be the positive side because positive side of the battery is towards this side, and this is negative side. This side is closer to negative side of the battery. See here, this is positive side, right? Positive side of the battery, this is positive side, negative, negative. Now this must be connected to, how will my voltage change now? That is a question. So I need to change my current. I am going to vary the current. So for that I require a rheostat. What my rheostat is going to do, by changing resistance here in this place, I am going to change the resistance. By changing the resistance, I am going to vary the current, and by varying the current my voltage is going to get changed, and that way I am going to measure different voltage and current value. So I will change the resistance in this rheostat. By changing the resistance here, current value gets changed, and then I'm going to measure the voltage across my wire. So what all do I require? Now, what all did I tell? Obviously, I need to measure current. So my tabular column is going to consist of serial number, at least 5 readings we require. Okay, 1, 2, 3, 4, 5 readings. And then what you're going to do? You require observed current. What current are you observing? Observed current. Since current value may not be correct, if your ammeter is not starting from 0, if it is having some 0 error, then you need to write the corrected value. But since ours doesn't require a corrected value, our ammeter is accurate, we will assume. So observed current, observed voltage. For different values of current, we are going to take different values of voltage by varying this rheostat. And then we are going to divide V by I. This voltage divided by current. We are going to get the resistance. This is going to give me my resistance, because resistance is V by I. So we started with this formula. We require voltage and we require current. So we are going to measure current, we are going to measure voltage, we are going to divide both of them 5 times. 5 readings we are going to take. And by doing that, we will take the average of this. We take the average of this V by I. That is going to give me my resistance. Once you get resistance, can you find resistivity? Resistivity is equal to resistance you have got from here. Substitute resistance value here. Find the area of the wire. Area of the wire is nothing but pi r square. You can find the radius using a screw gauge. Screw gauge, using that you find an area. Diameter you can find, and you can take the half of diameter. Or if you want the formula to be in diameter, let me give the formula. Radius is nothing but diameter by 2 whole square, which will be equal to pi d square by 4. You can use directly this formula as well. This is the formula for area if you know the diameter. So then divided by L. This is going to give me my final reading. So what you are going to do, take this resistance value, add pi d square by 4 whole divided by length. This is going to give you the final reading of resistivity. So you must be very careful. The unit of resistivity is what? Ohms. Area unit is meter square, length unit is meter. See, ohms, meter square by meter is meter. So ohm meter. Ohm meter is the unit of resistivity. Forgetting the unit is going to make you lose the marks. So make sure you don't forget the unit. This is the diagram. So starting from here, what did we do first? We draw a diagram, positive, negative side of the battery. Then positive side of the battery to positive end of the ammeter. An ammeter is connected in series with the resistance wire, and voltmeter is connected parallel to the resistance wire. Then this is connected to the rheostat. Then rheostat is connected to the key, because some batteries do not have switch on and off option. Our majority batteries nowadays have a switch on and switch off, but you don't have a switch on and switch off, then you can use a key to turn on and turn off the circuit. Whenever you want to off it, you can just remove the key. So this is the entire circuit. This is the way you do the experiment. Next what you must know is, find the resistance of a given wire using meter bridge. Now how do I find the resistance of any wire using a meter bridge? So to find the resistance of a wire using meter bridge works on the principle of balanced Wheatstone bridge network. All of you know balanced Wheatstone bridge network. When a Wheatstone bridge is balanced, the current flowing in between that is zero. So basically what we do in this circuit, here we require a resistance box whose resistance we know. Okay, so suppose we know the resistance of this resistance box. The resistance of resistance box is S, shunt. Okay, shunt means the known resistance. Our resistance box has a resistance S, shunt, and this resistance box is attached to, see, this is how my meter bridge looks like. Here it has 1 meter wire, 1 meter long wire, and this is connected to battery. This is how my circuit is. In between this, see, in middle of this we have a galvanometer which is attached here. Okay, so two empty ends here, two open ends. In one open end I attach a resistance box whose known resistance is known as S, shunt, and other place I attach a unknown resistance wire whose resistance I need to find out. Something whose resistance I need to find out. I don't know the resistance of that. So for using that, for finding that, I use a meter bridge. Now what I do, this is unknown resistance X. Suppose I don't know the value of this X. I don't know how much is this X value. So I need to find that out. All of us know that resistance is directly proportional to length of the wire. I told previously, right? Resistance depends on the length of the wire. It's directly proportional. Area of the wire is not getting changed here. This area of this wire will not get changed. Area is constant. So it depends directly on length, resistance. So this wire is 1 meter. I told you wire length is 1 meter. So that means 100 centimeter. Correct? So now what I can write is, in a balanced Wheatstone bridge network, this resistance divided by this resistance will be equal to this resistance divided by this resistance, right? So I can write S divided by this resistance will be nothing but how much, length of the wire. So whatever length you got when you balance this, when the current flowing through galvanometer was zero, that is called balanced state. In the balanced state, whatever length you were getting, that will be equal to x divided by this will be 100 minus L, because the entire length is 100 centimeter. So this remaining length will be 100 minus L centimeter. So from here I can get x value, unknown resistance, is equal to S into 100 minus L whole divided by L, and this is the formula for my unknown resistance, S into 100 minus L by L. So how will you do the experiment? Here, to do the experiment, you are going to attach a wire here. You are going to attach a wire here, and you are going to attach a wire here, and then one you are going to attach a wire here, and then what you are going to do, basically you are going to measure the different values of current. So basically what you will do, you are going to measure different length. Okay, I know the value of the shunt. I'm going to take a resistance here, the value which I know, and I'm going to find the balancing length, and I'm going to substitute that. So what all readings should I take? I'm going to take different readings of resistance box. I require a resistance box whose resistance I know, which can also be called as S. So suppose I took 10 ohms first, 20 ohms next, 30 ohms next, like that. Here you can write serial number 1 to 5. 5 readings you are going to take of known resistance. Then what you are going to do, you are going to find the balancing length. Balancing length you are going to get, suppose 20 centimeter, 30 centimeter, 40 centimeter, some centimeters. Then you are going to find 100 minus L, because our formula requires all these, right? Our formula requires 100 minus L, all those. Then you are going to find the X by substituting in this formula different values of X. Then you are going to find the average of that X. If you find the average, you will get the value of our unknown resistance. That's it. It's a very simple experiment. Then you can write the result. The final value of resistance for given wire was found to be dash ohms. Unit of resistance is ohms. So you must be careful with that. So to determine the resistance of galvanometer by half deflection method. Now this experiment, lot of students get confused. What is the principle behind this? What is half deflection method? What is figure of merit? So you must know That figure of merit is nothing but, figure of merit means how much current, how much current I causes 1 unit deflection in galvanometer. 1 unit deflection in galvanometer means what? Suppose if I pass 2 ampere current, my galvanometer needle from 0 it comes to this one division. My galvanometer needle comes here. For how much current? 2 ampere current. So how much is my figure of merit? 2. Because 2 ampere per division. 2 ampere current is flowing for one division, per division. That is the meaning. Okay, so figure of merit unit is, figure of merit unit will be ampere per division. That is the reason. Figure of merit formula. Now because I don't have time to explain lots of things now in detail, so only thing you can remember is figure of merit is equal to E by theta, because angle, whatever angle for one deviation you're finding, right? So theta divided by resistance plus resistance of galvanometer. You're going to find the resistance plus resistance of galvanometer, whatever resistance you have, whatever resistance you took plus resistance of galvanometer. Galvanometer has its own resistance. How does a galvanometer work? Galvanometer basically has a magnet inside and a coil inside. When the coil is going to carry current, the galvanometer is going to deflect towards the side. Because of current, magnetic field is produced and the galvanometer gets attracted towards north or south pole, something. So basically those are the principle how it basically works, galvanometer. So galvanometer has a wire inside it, so obviously it will have a resistance, right? So to find figure of merit, what all do you require? You require E, you require theta, you require resistance, you require G. So basically the tabular column should look like, you are going to have a serial number. Let me talk about the circuit diagram first. So circuit diagram of figure of merit is going to be like, obviously you require a battery, you require a battery. Battery is attached to key because our battery does not have a switch, so we use a key. Otherwise key is not required. The purpose of the key is just like acting like a switch. Then here you have a resistance, known resistance, because we require some known resistance, and that is attached to galvanometer, that is unknown resistance. That's it. This is my circuit for figure of merit. Resistance box attached in series with galvanometer. Now what we require, we require along with our galvanometer some small resistance as well. Parallel to galvanometer we are going to attach one small resistance and we are going to connect and disconnect this. When you connect it, you are going to measure the resistance of galvanometer, and if you don't connect this, you are going to this circuit. See, if there is no shunt, this circuit is circuit of figure of merit, correct? This circuit is the circuit diagram of figure of merit. This circuit is the circuit of figure of merit. Figure of merit diagram, if I attach a shunt resistance along with key parallel to galvanometer, this becomes the diagram of half deflection method. So in half deflection method, first you are going to measure the, because for figure of merit we require resistance and galvanometer, so all those, so that's why we have this circuit. Okay, so now what you are going to do, basically you require, half deflection method is nothing but you are going to use high resistance first. You are going to use high resistance and then you are going to measure the deflection by putting high resistance here. What is the reading you are going to get in galvanometer? This key is going to be unplugged, this is not attached, this part is not attached. That is the meaning of removing key from here. So I'm going to measure the resistance, high resistance I'm going to give some value of high resistance, then I'm going to measure how many deviations I'm getting, what is the value. Suppose I got 20, my galvanometer is showing a reading of 20 here. Then what I'm going to do, I am going to attach this key now. Now I need to attach this key. Previously there was no key here, right? So now I require that key. Now I will attach, now I will make this connection basically. Then what I'm going to do, I'm going to adjust this S value such a way that I'm going to, first I need to write half of this, okay, half of theta. Half of theta will be how much? 10. because half deflection method I require half. So when will I get this 10 reading? I get this 10 reading when my shunt resistance, suppose I took 50 ohms here, when I take uh, 30 ohms, 40 ohms, some reading, whatever reading here for shunt resistance value, that is going to give me 10 ohms reading here. Okay, so first I got 20 ohms resistance. To get 10 ohm, not resistance, sorry, first I got 20 deflection. To get 10 deflection, what is the shunt that I should attach? I'm going to find that shunt resistance value, this resistance value, and then I'm going to substitute in this formula. gs is equal to G is equal to, sorry, galvanometer resistance is equal to Rs by R minus S. Whatever R you took minus S by numerator you have Rs. So you're going to find the value of G. Then if you substitute the value of G here, you can find the K. So for figure of merit you have diagram, voltage you are going to measure, resistance you are going to measure, theta you are going to measure, K is equal to E by theta into R plus G. E is nothing but voltage, okay, whatever volt battery you took, how much volt battery you took. This is the diagram for tabular column for figure of merit. Now you have frequency of AC mains. Frequency of AC mains using sonometer. In this experiment, what you're going to do, basically you're going to consist of a sonometer. Sonometer is nothing but you have a device here, wire will be present here, you're going to put weights here, different weights, and then you're going to measure the vibrating frequency. Here you have a AC source, and this AC source is connected to a electromagnet. So electromagnet, what is going to happen? This electromagnet is going to attract this wire, because this wire is made up of iron. Once it is going to attract it, once it's going to repel it, because continuously the direction is changing. So it is going to vary continuously. It is attracting, it's not attracting, it's attracting, it's not attracting. So because of that, there will be a frequency here. This wire will start oscillating. On top of this, you are going to put a paper rider, and by putting a paper rider, you are going to see when the paper rider is falling, what is the maximum frequency at which it is oscillating. So by measuring the frequency of oscillation of this, that is called as resonance frequency. Resonance frequency means when the paper is falling, the highest frequency. So you are going to take load, you're going to put a weight here, right? So first you put different weights, then you're going to measure the tension, force, how much force this weight is going to put, that is called tension. So 1 kg weight puts a force of 10 newton, 2 kg weight puts a force of 20 newton, like that. So half kg weight, suppose you took 0.5 kg, that will put a force of 0.5 into 10, so 5 newton, correct? So that is the situation, 5 newton, basically 9.8, you need to multiply by 9.8. I have to show you, I have multiplied by 10 because anyways it's close. So load increasing value, you are going to increase the load, you are going to decrease the load, and then you are going to measure the mean length, you are going to measure the length, right? So load increasing length you are going to measure, L2 you are going to measure, you are going to find the average of L1 plus L2 divided by 2, and then you are going to finally find the frequency here in the final column. Frequency is equal to 1 by 2L into root of T by M. So what all you require? Frequency is equal to 1 by 2L, that's why you require, and you require tension. So first you need to find the tension, then you are going to find the M. M is length, okay, mass per unit length of wire, whatever our wire had mass per unit length, and frequency formula is nothing but rho by 2, whatever value you are getting for this, that if you divide by 2 you are going to get the frequency. So this is our ultimate frequency of our AC source. And convex lens, this is again very simple experiment. You are going to take a convex lens, you are going to take a convex lens, behind that you are going to place our object, behind that we are going to place our object. I have shown object below this line because object is placed little lower in our case. Then what happens, this light will pass like this, it goes like this, then from here whatever rays are passing, you are going to get the image of the object. So basically you are going to find where your object was placed. Our object is generally placed at origin, okay, I'm going to place my object at origin, then I'm going to find where is my image formed, and for seeing where my image is formed, I have another needle here, I'm going to make both the needle coincide. There is a needle before placed here, that needle should coincide with the image needle, so I'm going to find this distance. So suppose this distance is 0, From 0, where is my lens placed? I am going to adjust my lens, right, so that I get an image. So this distance will be, suppose, 10 centimeter. This distance is, suppose, 50 centimeter. So how much will this distance be? This will be 50 minus 10, correct? So that is how you are going to find lens minus, this is lens distance. See, this distance is called, let me show you again properly. This is my lens, this is my image. If I subtract image minus lens, I get the actual image distance. This is my image distance, which is called as V, and this is my object distance. Got it? So to find image distance, I need to subtract both. Understood? So you have a table, you can draw the table, you are going to find different values of lens. It's a very simple experiment. Again, you are going to find uh, 4 readings, you are going to take multiple readings, you are going to find where is our object needle, and you are going to find where is our image needle is a dash. Then you are going to find object distance will be nothing but lens minus a object. Since my object is 0, wherever your lens is placed, that only will be your object distance. And similarly, you are going to find image distance. Image distance will be lens minus image distance. And here you will have 1 by u, 1 by v, and then f is equal to uv by u minus v. That is going to give you focal length. You can find mean of that average. So you get your focal length. You can draw a graph of u and v. If you draw a graph of u versus v, your u values will be obviously negative because u is measured behind, and v values will be positive because you're measuring front. So that's why I took negative axis here and positive axis of v. So I'm going to draw a graph of u versus v. I'm going to get a graph like this. At 45 degree, when you measure the length, you are going to get the focal length if you divide that by 2. Then similarly, you can draw 1 by v versus 1 by u graph. 1 by v versus 1 by u graph comes like this. Then you can find the focal length using the graph. So it's a very simple experiment. Next, minimum deviation. Basically, angle of minimum deviation means for what angle. See, this is my prism. Here I have my normal. Here I am going to place my incident ray. Incident ray is getting deviated like this and coming like this. So actually my incident ray had to go like this, but my incident reflected ray is coming like this. This is known as angle of deviation. So at what angle of incidence? This is angle of incidence, this is angle of deviation. So basically, at what angle of this incidence I am going to get minimum deviation here. Almost my line is going straight. See, there is no deviation at all. Almost my line is going straight. That is known as angle of minimum deviation. Okay, this will be considered as angle of minimum deviation. So you measure the angle of deviation between, my ray had to go like this. This is my incident ray, this is my normal incident ray. Actually my ray had to go like this. This is how my ray had gone, reflected ray. But my ray, if there was no prism, how my ray would have gone? My ray would have gone like this. So there is an angle between both, difference. This is known as angle of deviation, not minimum deviation. This is known as angle of deviation. So there is a formula to find angle of minimum deviation, and you can measure angle of minimum deviation. Again, you can draw a graph for different values. You are going to take different incident values, 30 degree, 45 degree, 50 degree, different values. You are going to get a graph like this. The place where you are getting lowest, at what angle you are getting lowest value, that is called as angle of minimum deviation. This is my deviation. Okay, so this angle is considered as angle of minimum deviation because here you are getting minimum value of deviation. Next, you are having refractive index of a glass slab using traveling microscope. This is again very simple experiment. What you are going to do, you are going to take a glass slab. You take a glass slab, you are going to measure first position of this cross here. So to measure this position, here I draw cross. Okay, I draw cross here. So I'm going to measure this. Where is this cross located? What is the position of my cross? Then I'm going to measure the position of my cross with glass on it. When I keep this glass slab on top of that, I will get the glass cross position here. So my cross is present here. This is my image distance. This was my object. This is my image. Next I'm going to put powder on top of this, and I'm going to measure the powder. So powder distance will come to this. This is my powder distance. Dust particles. Lycopodium powder we use. Okay. So now I need to know the thickness of the glass. That is my actual distance, correct? This distance is my actual distance. So that will be what? This distance is going to be how much? I will show it in blue color. This distance is going to be how much? Because that is the actual thickness of the glass, or that is the actual distance of my object. Where is my object actually present from the surface? Here. So this will be nothing but object distance, what you measured before, object minus image. If you do, you are going to get this thickness. Then image distance, how do you find? Sorry, not object minus image. You are going to do object minus this, right? This portion. This portion is nothing but my distance. Object minus surface. Image is going to be again object minus image is going to give you my image distance. So similarly you can use it and you can find the formula. Refractive index is equal to real depth by upper end depth. So going to find the real depth, you are going to find the upper end depth. For that you are going to draw the columns. You are going to measure the mark without slab. Without slab you are measuring the mark. Then you are measuring the mark with slab. Then you are measuring the dust particles. Then you are subtracting and finding the final reading. So real depth, if you divide by upper end depth, you will get the refractive index. So last you can write the result. Refractive index was found to be 1.5 or something. So this is the entire process, how you are going to do the experiment here. Then PN junction diode is very easy. In PN junction diode, basically what you do, forward bias means when PN junction diode, see if this is my diode, PN, this is my diode. If diode is attached, positive side is attached to positive side of the battery, it is considered as a forward bias. And if it is passing reverse, if it is connected reverse, then it is considered as reverse bias. If it is connected reverse, then it is considered as reverse bias, because in reverse bias. So you are going to get a graph like this. In positive, you are going, in forward bias the current is going to increase properly, but in reverse bias it is going to not increase significantly. And here you are going to measure the knee voltage, and this is considered as breakdown voltage, because here the diode is resisting the current. Even if you are increasing the voltage, it resists the current, but after a certain point it breaks. So it is called breakdown voltage. Okay, so this is going to be in volt, this is going to be in milliampere, because forward bias, this is going to be in microampere, very small current in reverse bias. So this is the entire experiments that are present. Thank you very much. Subscribe.